Welcome to the fourth lesson in our Unit 7. Today we're moving away from our vectors and into our circle properties. And our goal today is to use properties of circles to solve for unknown angles and lengths. So back in grade 8, grade 9, we learned all kinds of theorems that went with geometry, like we had the isosceles triangle theorem that told us if two sides of a triangle were equal to each other, then their opposite angles. The angles opposite those sides would be equal to each other. We had alternate angles when we worked with parallel lines, so we called that a Z pattern. With parallel lines, we also had the F pattern and the C pattern. So it's all that kind of stuff, but this time we're learning properties for circles. So it's just an extension of that angle type stuff that we learned back in grade 8 and grade 9. Before we begin those properties, though, I want to talk about some vocabulary that you'll need to know. Some of this will be like, yeah, I know already, let's move on. And some of it's like, I didn't know that, and we actually need to spend some time with this. So first of all, if we have a line that goes across a circle through the center, so I'm just going to put a dot here to represent that is the center, and often we use the letter O to represent the origin or the center of our circle. If we're talking about the line that goes directly across from one side to the other through the center, we know that that is called a diameter. So we want to label this blue line in here the diameter. You might be able to write it right on there if you can turn your page, but I am having a little difficulty with that. Now, if you have a line that goes from the center to the outside, we call that, of course, a radius. If we have more than one, we call them radii. Radius. So we have that. And what I have drawn up here is a line that just touches the circle at a single point, and that is called a tangent. That is a tangent to the circle. It's a line that's only intersecting that circle at one specific point. It's just touching. So there's some tangent properties that we'll be talking about in a bit. Then my diagram got a little full here, so from here I drew a second circle. Again, I'm going to mark this as an O, so that's representing the center point of the circle. So what I've drawn here are two radii for my circle. So these are two radii, and the angle that's formed by two radii, this angle in here, is called a central angle. So that is called the central angle. And it's an angle that's formed by between two radii of a circle. Central angle. Okay, so we have that definition in there. And between those two radii, I'm just going to use a different color. In fact, I might try a highlighter here because I don't want to cover up that central angle. If I'm talking about all of this that I'm going to highlight in green here, if I talk about all of that, that section there is actually called a sector. Okay, so this is known as a sector of a circle. So it's kind of like a section or sector of a circle. I'm also going to trace out this, and that is an arc of the circle. Okay, just a part of the circumference is the arc, or is an arc. So this terminology is probably a lot newer to you. Okay, so part of the circle circumference. Probably should have typed that in instead. All right, we also have this line up here at the top, and it's not going through the center at all. It just goes from one point on the circumference to another point and joins them together, and that is called a chord. So a chord for the circle. It just joins 2 points on the circumference of the circle together. So actually a diameter is a chord. It just happens to be a special chord that passes through the center of the circle. Okay, so we have that there. And then this piece, again, I'm going to use the highlighter here. I might use a different color just so you can see. So if I have this peachy, pinkish, reddish color in here, this section is not called a sector. This one's called a segment. Okay, so this piece in here is called a segment. Okay, so lots of terminology here so far. Okay, and I've also added the, what I wrote there was part of the circle circumference, but I actually typed it out so it's a little easier to read, part of the circumference of the circle there. All right, so those are definitions you need to be comfortable with or understand what we're talking about when I use these words. Now we're going to actually start with the theorems that we're going to be talking about. And one of the things we need to talk about are inscribed angle theorems. There's 3 different inscribed angle theorems we're looking at, but first we're going to define what an inscribed angle is. And I'll do that on the next slide here. All right, our definition of an inscribed angle is an angle that's formed by connecting 2 points on the circumference of a circle to another point on the circumference. So if we just go from one point to another point on the circumference, that's going to give us a chord. But what I have here is actually 3 points on the circumference. So I'm going to use my highlighter here and just highlight 3 points. So my 1 point could be here. My second point could be here, and here is a third point. So we've got 2 points on the circumference, and then we have the third point happening there. What I have here, and what I intended to have here, which I couldn't do very well with my drawing tool on my software, is I meant for this to be a diameter here. So I'm just going to mark a dot in the center and label it O. Whenever you see a dot with an O, that's assumed to be the center of the circle. Okay, that's by definition. Now, when you have a diameter or a chord that passes through the center of the circle, and then you've got an angle that's subtended or created, the third part or the third point on that circumference, if your base or your chord is the diameter, the angle that's inscribed there is going to be a 90-degree angle, always, no matter what. Okay, so this angle up in the top corner is a 90-degree angle. So I'm just going to summarize that in words. And so my summary is an angle subtended by or inscribed on a diameter of a circle will always be 90 degrees. So it's sitting on that diameter. It's that inscribed angle there. It will always be 90 degrees no matter what. All right, so we're actually saying that that angle is being subtended by this arc, and I'm going to trace out the arc. Okay, so if I look at that as being my arc that the angle's kind of sitting on, that's what subtended means. So if I look at my next example, I could look at this arc right here, and I could look at a couple of angles that are subtended by that arc, that are sitting on that arc. So if I go with my inscribed angle being this one, I'm just going to trace that out. Here's my inscribed angle up at the top here. Okay, it's sitting on that green arc. I also have another angle that's sitting on that green arc, and I'm going to highlight that, and that's this angle right in here. Now, if you have 2 inscribed angles that are subtended by the same arc, those 2 inscribed angles will be equal to each other. So this value here, let me get a marker, that value, we'll call that x, that angle will also be x over here. They're equal to one another. Kind of a cool theorem. Some people refer to that as the bow tie because it kind of looks like a fancy, crazy looking, clownish looking bow tie, but and if you don't know what a bow tie is, you'll have to Google that. Now here's the kind of cool thing. I could also flip this around and look at a different arc. So I could look at the arc over here, and then I have this angle up in the top, in the bottom corner here, and the angle here. They would be equivalent to each other. So I'd use a different letter. I wouldn't use x because it doesn't mean they're going to equal the x values, but they will be equal to each other. All right, the last inscribed angle theorem, it kind of reminds me of a Star Trek symbol if you know what Star Trek is all about. But that's only because I lived with a bunch of nerdy Star Trek fans when I was in university, because I don't actually like Star Trek myself. You can decide if you believe that or not. All right, so again, I meant for this to be the O for origin, or O for center of the circle. So I'm just trying to grab my pen here. There we go, got the right tool. That's going to be O. So I have 2 radii there, and I have a central angle. Now there is a relationship between the central angle and this inscribed angle up here. Okay, they both are sitting on the arc formed down here. They're both subtended by this arc. And the theorem, and there's all kinds of geometry software things out there that you can test these things, but that central angle will always be twice as big as the inscribed angle. So my shaded blue angle is going to be double the red angle that I've outlined there. So if I call this one, the red one, X, I keep grabbing the wrong tool. Let me try this again. There we go. So if I call this one X, the red one angle X or X degrees, the one in here will be twice as big or 2 times X. Okay, so I have the definition there for that one. The central angle will be twice as big as the inscribed angle if they are both subtended by the same arc. They're both sitting on that same arc. So those are 3 inscribed angle theorems that you're going to need to know. There are 2 more theorems, and they are based on the tangents to the curves, and I'll do that in the next video, and then we'll do some examples on these.